Find the equation of the line that is parallel to this line here. So parallel means the slope is the same, so it's 3, and goes through this point. So let's use slope point form. Y minus y1 equals m x minus x1. We simply substitute x1 here and y1 here. So y minus 2 equals the slope 3, x minus 3. Using distribution, we have 3x minus 9. Adding 2 to both sides, we have y equals 3x minus 7. This here is a line that is parallel to this line here. Now previously we found that the slope is 3. Now we have another point. The y-intercept means x equals 0, and the y-intercept is 4. Again, we use slope point form. Y minus y1 equals m x minus x1. We substitute x1 and y1. Y minus 4 equals 3, x minus 0. So y minus 4 equals 3x. Finally, we have the slope-intercept form, y equals 3x plus 4. This line here is parallel to the original line and has a y-intercept of 4. Again, we have slope equals 3. When we're finding the x-intercept, we set the opposite of x, y equals 0. We use slope point formula again. Y minus y1 equals m x minus x1, and we substitute. So we have y minus 0 equals 3 x minus 6. Using distribution, we have y equals 3x minus 18. Let's find an equation of a line that is perpendicular to this line here and goes through this point. So the slope for this line is 2. So the perpendicular slope is a negative reciprocal. So instead of 2 over 1, we have negative 1/2. Let's use the slope point form. Y minus y1 equals m x minus x1. We have y minus 1 equals negative 1/2 x minus 4. So we have distribution here, negative 1/2 x plus 1/2 times 4 is 2. But we add 1 to both sides. So we have y equals negative 1/2 x plus 3 as the perpendicular line. Now, given the perpendicular slope, negative 1/2, we're now trying to find the equation that goes to the origin. 0, 0 is the point. So y minus y1 equals m x minus x1 is a slope point form. So we substitute 0 and 0. So we have y, using distribution, equals negative 1/2 x as the perpendicular line that goes through the origin. We draw a line through the 2 points in the gas time graph below. So we can see that as time passes, we're losing gas volume, and eventually we'll hit the x-axis when we run out of gas. So the question is, when exactly do we run out of gas? Let's label these points. We have 1, 2, 3, 4, 5 as time. So this point here is 2, we have 5, 6, 7, 8, 9, 10. Whereas this point here is 4, 9. Let's find the equation. The slope is rise over run. We have 9 minus 10, and we have 4 minus 2. So we have negative 1 over 2 as the slope. We can use either point. We'll just use the first point using slope point form. Y minus y1 equals the slope x minus x1. If we want to, we can even rewrite this as slope point form. So we have y equals -1/2 x plus 1. Adding 10 to both sides, we have -1/2 x plus 11. And the question is, when do we run out of gas? We can use y, we can even use v. Instead of using x, we can use t for time as well, same thing. So the question is, when you run out of gas, is when the volume is 0. Multiplying both sides by 2, we have 0 equals -t plus 22. And we'll throw this t to the left. We have positive t equals 22. So 22 hours later, we run out of gas.